Hello, I'm Tarte, math teacher. In my private tutoring, I have been helping some geometry students work a particular type of problem which can be solved by algebra and also can be solved by geometry. And the algebraic solution is much more complicated than the geometry solution. The geometric solution is quite simple. Their teachers, however, in this geometry course are insisting that the students work the problem by algebra and forbid them to do a geometric solution of it, in spite of the fact that the geometric solution is much simpler and that this is a geometry problem. And I do not understand those teachers insisting on that. So I'm going to propose the problem to you and then go over with you the algebraic solution and then the geometry solution. And I want to demonstrate that this is a very good example of how these two branches of mathematics, algebra and geometry, can shed light on each other. Here's the problem. We have a line with slope 3/4 and the line contains the point 2, 1. Now there are 2 points on the line, each 5 units away from that point 2, 1. One of the 2 points is higher than the point 2, 1. The other one is lower than the point 2, 1. And the question is, what are the coordinates of those 2 points? We can begin by writing an equation of that line in what's called point-slope form. Y minus the y of that given point, that's y minus 1, equals the slope 3/4 times x minus the x of that point, that's x minus 2. So we have y minus 1 equals 3/4 times x minus 2, and we can distribute the 3/4 to get y minus 1 equals 3/4 x minus 3/2. Now we are looking for a couple of points, each of which is 5 units away from the point 2, 1 on that line. So I'm going to use the distance formula, which says that that distance, 5, equals the square root of x minus the x coordinate of that point, that's x minus 2 squared, plus y minus the y coordinate of that point, that's y minus 1 squared. That distance formula is based on the Pythagorean equation a squared plus b squared equals c squared. That 5 is basically a slanted distance. It is the hypotenuse of a right triangle, and I will try to clarify that point when I show the geometric solution. But now I square both sides of that equation, which makes the square root sign disappear on the right side, and I have 25 equals x minus 2 squared plus, and in place of y minus 1, I substitute what I have right here, 3/4 x minus 3/2 squared. Now I square those two binomials on the right side of the equation, and I have this equation, 25 equals x squared minus 4x plus 4 plus 9/16 x squared minus 9/4 x plus 9/4. To get rid of those fractions, I multiply this equation by 16, and I get 400 equals 16x squared minus 64x plus 64 plus 9x squared minus 36x plus 36. I combine like terms and get everything on one side, and I have 25x squared minus 100x minus 300 equals 0. I divide that equation by 25, and I get x squared minus 4x minus 12 equals 0. I factor the left side, right here, into x minus 6 times x plus 2 equals 0. I set each factor equal to 0, and I get two values of x. X equals 6, x equals -2. I substitute those values of x into the equation that begins y minus 1, either one of these equations, and I get y values. For 6, the y value is 4, and for x being -2, the y value is -2. So I have these coordinates, 6, 4, and -2, -2. Those are the coordinates that are asked for, the coordinates of the 2 points on the line, each 5 units away from 2, 1. So that's the algebraic solution. But now I'd like for you to look at the geometric solution. Here's the point 2, 1, and with a slope of 3/4, that's rise over run, I went up 3 and over 4, and also went down 3 and to the left 4, and there you see the line. Notice the rise over run 3 and 4 forms a pair of right triangles, each with legs lengths 3 and 4. That's the familiar 3, 4, 5 right triangle. So this slanted distance is 5, and so is this slanted distance. And so the 2 points that are asked for are this point, that's 5 units above the point 2, 1, and this point, that's 5 units below the point 2, 1 on the line. And what are the coordinates of those points? The upper one is 6, 4, and the lower one is -2, -2. Those are the same results that we got by this algebraic solution. Notice how much simpler the geometric solution is than the algebraic solution. I do not understand why in a geometry course the teacher would insist that the student work it only algebraically and no reference is made to the geometric solution. If I were still teaching in the classroom, I would certainly refer to both solutions, because I think this is a beautiful example of how geometry and algebra can shed light on each other. Thank you for watching this video.